Chapter 6, Section 7, Problems Involving Proportions. Well, there's some language in here. A ratio means fraction, or a ratio of two quantities is their quotient. Fractions really are divisions. Answer to a division is a quotient. Just kind of pull all this language together. So they're going to have ratios or fractions or answers to divisions, and we're going to make something called a proportion with those, which just means equal fractions. So when we have like this example 37%, percent really means hundredths, so this is a fraction, 37 over 100 right here. That's a ratio. So they're introducing, percents we run into a lot. That really is a fraction, which could set up a way to do a proportion or set up two fractions equal to each other. And we do this a lot we make proportions a lot. We've never called it that much, but like if I need to add fractions like 1/2 plus 1/3, I need to get a common denominator, so it'd be 6. Well, how do I change 1/2 into 6? Well, I need to multiply the denominator 2 by 3 to get 6. And then I put 3 in the numerator too, which is really what I'm doing is multiplying by 1 in a special way. I'm multiplying by 3 over 3. In other words, 3/6 is equal to 1/2 because all I did was multiply by 1 to make that change, and basically I've proven that those two fractions are proportional, and in other words they're equal to each other. So we've been doing equal fraction stuff for quite a while. We've just probably not used this word very much. So proportion means fractions that are equal to each other. Well, in geometry there's a lot of instances where this proportionality is important to solve problems, and they're going to define some stuff in geometry about triangles and stuff like that. This first one is that when things are similar, if I have two triangles that are similar, that means to be similar, their corresponding angles have to have the same measure and their corresponding sides are proportional. And things to note usually about how you introduce two different triangles is the order of these letters make a difference. They're using the vertexes, or these points where the sides meet, and they put them in this order. It isn't just necessarily because it's supposed to be in alphabetical order. I could go CAB here, but then I'd have to go TRS here, because I want these corresponding vertexes to match up when I name these triangles. And that's what they say. Well, angle A, which is right here, this angle, and angle R, this angle, are the same because of similar triangles. And they go through all the corresponding angles here for B and S and C and T. Now also we can make a proportion of all the sides. In other words, I can make fractions of the corresponding sides, and they'll be equal to each other as long as I keep them in order. Remember, division, it has no commutative property, so I got to make sure if I start with the bigger triangle in the numerator and put the smaller triangle in the denominator, I better do that for every side. In this case, they do the smaller triangle as the numerator, over its corresponding side is the denominator. So we get this fraction A over R, and then B over S, C over T are fractions that are all equal because similar triangles have to be proportional. So how do I use this information to solve these kinds of problems? So we have triangles ABC and XYZ are similar, and first you need to know what that means. It means corresponding angles are congruent. Congruent's another word for measured the same. And corresponding side lengths of the sides, if you make fractions out of those, they'll be equal, or another word for that is they are proportional. So when they ask us, they say I have these two triangles, they're similar, solve for Z if x equals 10, a equals 8, and c equals 5. Now I don't think they'd ever just define variables like that without drawing a picture. But they do some things here, and they talk about this a little bit right here when they're drawing this, that the small x, like you can see this one, the small z is opposite angle z, which is this capital Z. So this 10 right here, if I needed to use a variable for it, the length of this side, it would be x, lowercase x. This would be a, this would be lowercase c, and this would be lowercase b, y, right here, lowercase y. Well, according to similar triangles, if I make proportions out of that, first I have to make fractions out of the side, and they took z over 5 right here, this z over this corresponding side length, and then they got 10, which is from this distance right here, and it corresponds with this one, 8. And then they have here, since z over 5 equals 10 over 8, then 5 over z would equal 8 over 10, and 5/8 would equal z over 10, or, they're basically manipulating this different ways to look at proportions, because we can write fractions a lot of different ways. In other words, what they're really doing is you're multiplying or adding and subtracting. As long as you do it to both sides of the equal sign, you can follow the rules. So these are really kind of shortcuts to understanding how to solve these kinds of problems. So now we have a equation, right? And from this proportion, so we solve for z, which I would just add, or multiply both sides by 5. You could do that one step and you'll get 50 over 80. Well, in architecture, here's another example, is blueprints are scale drawings of buildings representing the architect's plan. Now, it wouldn't make much sense to draw a floor plan out the same size as the actual floor. So you can make floor plans of these things. They're talking about this thing called scale, and what it means is the lengths of the paper are proportional to the lengths on the actual floor of this building. And that's what they're explaining here. If a 10-foot long bedroom represents 2.5 inches here, which they're showing here, they want to know how much space do I need, or what do I need to move and draw this next room if I want it to be 12 feet out from that. Well, we'll set up proportions. We have this width that we're looking for, W, or wall, or I'm not sure what they use for that. And I can say W, this thing I don't know, over 12 should equal, because these things are supposed to be proportional, should equal 2.5 over 10. And you'd solve this. Again, I don't think clearing fractions is that important. You're going to end up multiplying by the same stuff. Why not just multiply both sides by 12 and you'll get W, rather than go to this 5W and so on. But some of that's just preference, and for some reason the book thinks that's a better problem solving skill that way. So anyhow, they find out the W, the width is 3 inches. So in other words, what does that 3 mean? It means when you draw this diagram, you're going to need to go 3 more inches out, go down to match up, and make this 3 inches so you have the right perspective or proportion on your building when you add new room. Okay. This next example is text messaging. It's talking about Brent had sent or received 384 messages in 8 days. How many text messages would he send or receive in 30 days? Well, this deal, they start defining the variables right away, which is good. They say let X equal the number of text messages Brent would send or receive in 30 days. So we form a proportion in which the ratio of the number of text messages to the number of days is expressed in 2 ways. One is, I say, 384 messages in 8 days that was given to us. And then I have this amount of text messages that I don't know, which is x, over 30 days. Well, these are equal to each other. I can solve this by multiplying 30 times both sides, and I end up with x equals 1040. Now what does that mean? That means if the rate stays the same as it did for these 8 days, after 30 days there'll be 1440 text messages sent or received. Okay, I think this is last example, yeah. Wildlife population. To determine the number of brook trout in River Denny's, Cape Brighton, Nova Scotia, a team of volunteers and professionals caught and marked 1,190 brook trout. Later they captured 915 brook trout, of which 24 were marked. Estimate the number of brook trout in River Denny's. Well, the solution, as usual, usually involves really early on. Let's start defining variables. Well, in this case, they say let capital T equal the brook trout population in this river. If we assume that the percentage of the marked trout is in the second group of trout captured is the same as the percentage of marked trout in the entire river, we can form a proportion in which this percentage is expressed in two ways. So I take the original marked, which is 1190, over its population that we don't know, should be equal to the marked trout over the total trout in the second group. Okay, because they tell us how many came in, right? Well, they clear fractions and solve, and they get T is equal to approximately 45,369. So based on that, if there's a lot of variables on when they captured those fish or counted them and whatever way they got them, they could tilt that. And I'm sure if they're really truly trying to get a good guess at how many actual fish are in that river, they'd probably do this study several times under different conditions. But that's what it's telling us, that there's about 45,369 brook trout in this specific river. So proportions, and other than some of the goofy ways they solve these equations with trying to clear fractions or something, though this one makes sense, but the other ones, I don't know why you just wouldn't solve for the variable you're looking for, is this proportion stuff is very powerful in setting up these kinds of problems. In fact, when you run into problems, you have some choices or different things that we've covered that'll come up in these word problems. So we want to try to use this, and I think it has a lot of advantages and can save a lot of time if you can figure out when these proportion can be used. Proportion, again, just means equal fractions. So good luck on the quiz and chapter test coming up.